Drive through almost any American neighborhood. You might see a white suburban house with vinyl siding, a red brick home with a front porch, a California house covered in stucco, or a modern home faced with stone. They look completely different from the outside. But imagine removing the siding, brick, paint, insulation, and drywall from one of those houses. Underneath, you would often find a framework of wooden studs, wooden beams, and wooden panels holding the structure together. And this isn't some unusual American building style. In 2024, about 94% of newly completed single-family homes in the United States were wood-framed. Think about that for a moment. A country filled with concrete, steel, brick, and modern engineering technology still builds the overwhelming majority of its new single-family houses around a wooden frame. But why? Was it simply because America had enormous forests? Not quite, because the real story doesn't begin with a tree. It begins with a tiny piece of metal, a nail. Why a nail mattered. Imagine an American carpenter building a house before industrial construction transformed the way homes were assembled. Instead of walking into a modern lumber yard and choosing stacks of identical boards, the carpenter worked with large pieces of timber that had to be measured, cut, shaped, and carefully joined together. A traditional timber frame could contain enormous wooden beams connected by precisely cut mortise and tenon joints and secured with wooden pegs. Every major connection required craftsmanship. A skilled carpenter wasn't simply assembling a pile of boards. He was creating a complicated wooden structure piece by piece. That meant building a house could require substantial amounts of skilled labor and time. But America, in the late 1700s and early 1800s, was changing rapidly. New settlements were spreading, towns were growing, cities were expanding, and more people needed homes, warehouses, stores, barns, and other buildings. The old way of building was useful, but it wasn't particularly well suited to a country that wanted to build quickly and repeatedly. Then, American manufacturers began changing something that looked almost insignificant: the nail. For much of history, nails were made by hand. A blacksmith heated a piece of iron, hammered it into shape, cut it, and formed the head. Every nail represented individual human labor. But during the late 1700s and early 1800s, American manufacturers developed machines for producing nails more efficiently. Machine-made cut nails became increasingly common. Instead of a blacksmith individually forging every nail, a machine could cut nails from sheets of iron in a much more repeatable manufacturing process. Picture the difference. On one side, a blacksmith standing over a hot forge, repeatedly hammering individual pieces of iron. On the other, an early industrial workshop producing large quantities of standardized nails. The nail had become a manufactured product, and that mattered because a standardized nail could connect standardized pieces of lumber much faster than a carpenter could create a complicated wooden joint. The nail didn't build the house by itself, but it helped make a completely different style of construction practical. And the next ingredient was already growing all around America: wood. I'll follow one of those trees into a commercial sawmill. Instead of treating the entire tree as one enormous piece of unique material, workers could cut the log into boards and planks. Sawmills increasingly supplied lumber in standardized dimensions. A builder could now receive piles of relatively uniform boards instead of individually shaping every structural beam from massive timbers. At the same time, transportation networks expanded. Horse-drawn wagons carried lumber along rough roads, while canals and eventually railroads moved enormous quantities of construction materials between growing communities. Wood was no longer simply something found in a forest. It was becoming part of an industrial supply chain. Trees became logs. Logs became standardized boards. Factories produced other standardized building components. Transportation carried those materials toward rapidly growing towns and cities. And now two things were coming together: standardized lumber and machine-made nails. The question was no longer just how to make a strong wooden building. The question became, how quickly could someone assemble one? 1930s. This is not the giant modern city surrounded by skyscrapers that you know today. Instead, imagine a young, rapidly growing city with rough streets, wooden buildings, horse-drawn wagons, Construction sites, piles of lumber, and workers rushing to build new structures. Chicago was expanding quickly. But rapid growth created a problem. There weren't enough highly skilled carpenters to construct every building using slow, labor-intensive traditional timber framing. Builders needed another approach. One early landmark in this story is a Chicago warehouse associated with George Snow in 1832. The exact origin of balloon framing is still debated by historians, and the old story that one person simply invented the entire system in 1 year is too neat. But the Chicago story reveals something important. Builders were experimenting with a new way to use smaller, standardized pieces of lumber and nails to create large structures. Instead of carefully crafting enormous timber joints, workers could assemble a lighter wooden framework from repeated pieces. It was faster. It required less specialized craftsmanship. And for a rapidly expanding city, that difference mattered. Imagine watching a traditional timber frame being built beside an early balloon frame structure. The traditional timber frame is dominated by massive wooden beams and carefully crafted joints. The balloon frame looks completely different. Instead of enormous beams carrying the entire structure, the walls are made from many relatively small wooden studs placed close together and fastened with nails. One board after another, one stud after another, one nail after another. The structure could be assembled from standardized lumber rather than requiring every major structural component to be individually carved and fitted. This construction method became known as balloon framing, and the name sounds almost ridiculous today. But the important part wasn't the name, it was the idea. A house could increasingly be assembled rather than painstakingly crafted. A worker didn't need to be a master timber frame carpenter to perform every structural connection. The building method was becoming compatible with ordinary workers, standardized materials, and rapidly produced components. And that meant something much bigger was happening. America wasn't simply learning how to build wooden houses, it was beginning to learn how to build many houses using the same basic system. Now imagine the entire system working together. At one end, forests supplied enormous quantities of timber. At sawmills, logs were cut into standardized boards. Factories produced increasingly standardized doors, windows, trim, and other building components. Manufacturers produced machine-made nails. Wagons, canals, and railroads moved these materials toward growing communities. And at the construction site, workers assembled the pieces into houses and other buildings. No single invention created this system. The important change was the way all of these technologies and economic forces worked together. Standardized lumber made repeated construction easier. Machine-made nails made fastening faster. Light frame construction reduced dependence on highly specialized timber framing skills. Transportation made materials available across a growing country, and rapidly expanding American towns created enormous demand for buildings. The house was slowly becoming something that could be built quickly, repeatedly, and at scale. But there was one enormous weakness in the system, and America was about to discover it in the worst possible way: fire. Imagine Chicago on a night in October 1871. Wooden buildings stand close together across large sections of the city. Then a fire begins. Flames spread from building to building. Wooden structures burn. Smoke fills the streets. The Great Chicago Fire destroys a huge part of the city. The disaster exposes the danger of dense urban construction that relies heavily on combustible materials and inadequate fire protection. After the fire, Chicago strengthens its building regulations and encourages more fire-resistant construction in certain parts of the city. Brick and stone become especially important in rebuilding areas. And suddenly, the future of wood construction seems uncertain. If wooden buildings can burn this easily, why keep building with wood? But something surprising happens. Wood framing doesn't disappear. The reason is simple. The fire had exposed a serious weakness, but the underlying system still offered enormous advantages in speed, labor, availability, and adaptability. So, instead of abandoning the system completely, builders continued changing it, and the next version would become even more familiar. Imagine an unfinished wooden house being built one floor at a time. Workers first construct a wooden floor platform. On top of that platform, they stand shorter wooden wall studs vertically and fasten them together. Then another floor platform is constructed. Then, another level of walls. This is the basic logic behind platform framing. Over time, platform framing gradually replaced balloon framing as the dominant modern approach. The change wasn't a single overnight invention. It evolved as construction practices, lumber dimensions, factory production, safety considerations, and building regulations changed. The result was a system that worked extremely well with standardized lumber and modern construction. A house could be divided into repeatable stages. Walls could be assembled on one level, floors could support the next level, and workers could continue building upward. The American wooden house had evolved again, but the most surprising part of the story was still waiting in the future. Because this wasn't just an old historical construction technique, it survived. Now return to modern America. A construction crew is building a new suburban house. From the outside, the finished home might eventually have white vinyl siding, red brick, gray stone, stucco, or another exterior finish. But during construction, before the walls are covered, the structure looks very different. You can see rows of wooden studs, wooden floor joists, wooden roof trusses, large sheets of structural wood panels covering the frame. Insulation will later fill the wall cavities. Drywall will cover the interior. Siding, brick, or another exterior finish will hide the wooden structure from view. But underneath the finished appearance is the same basic concept that transformed American construction generations ago. Standardized pieces assembled into a structural system. And the numbers show just how persistent that system has been. In 2024, census-based data analyzed by the National Association of Home Builders found that approximately 94% of newly completed U.S. single-family homes were wood-framed. After nearly 2 centuries of technological change, wood framing remains overwhelmingly dominant in this part of American housing. So why does America still build so many houses around wood? The answer isn't simply that America has forests, and it isn't because one inventor suddenly discovered the perfect way to build a house. The real story is a chain reaction. Forests supplied timber, sawmills turned trees into standardized lumber, machine-made cut nails made fastening faster. Light frame construction reduced the amount of specialized craftsmanship required. Transportation networks distributed construction materials. Growing cities and expanding communities created enormous demand for new buildings. Fires forced changes in codes and construction practices, and framing techniques evolved from balloon framing toward platform framing. Each development strengthened the others. Together, they created something much bigger than a wooden wall. They created an American housing system. So the next time you drive through an American neighborhood, look at those houses differently. You might see a brick house with a front porch, a white suburban house with vinyl siding, a California home covered in stucco, a modern house with stone on its exterior. But imagine peeling those visible layers away. Under the siding is sheathing. Behind the drywall are wall cavities. Inside those walls are rows of wooden studs. And holding those pieces together is a construction system that began taking shape almost 2 centuries ago. The story of the American wooden house isn't really the story of a country that simply had lots of trees. It's the story of what happened when wood, standardized lumber, machine-made nails, transportation, labor, and industrial production came together. America didn't just build with wood. It turned wood into a system for building houses quickly and repeatedly, and that system became so deeply embedded in American construction that, even today, roughly 94 out of every 100 newly completed single-family homes are still built around a wooden frame. So perhaps the next time you see an American house, don't just look at the house, look underneath it. Because sometimes, the thing that changes a country isn't a skyscraper, a machine, or a massive invention. Sometimes, it's just a board, a nail, and a faster way to put them together.